So hello guys, welcome back to our YouTube channel. From this video, we are going to start a new series on the topic of distillation. Particularly in this video, we are going to discuss about what is distillation, then on which laws are distillation dependent. We'll also discuss why a mixture does not have a multiple boiling points. Furthermore, we will also discuss why it is impossible to completely purify a mixture by distillation. And we will also look at an example on history of distillation, and at the end we will end by discussing about the applications of distillation. So now we will begin our video with what is distillation. Distillation refers to selective boiling and subsequent condensation of a component in a liquid mixture. It is a separation technique that can be used to either increase the concentration of a particular component in a mixture or to obtain almost pure components from the mixture. So the distillation technique is used for two main uses, which is either to increase the concentration or to obtain pure components from the mixture. And guys, it is important to note that the distillation is not a chemical reaction, but it can be considered as a physical separation process. So guys, distillation is a process which is used to separate the components in a liquid mixture which is based on the different boiling points. By heating the mixture, the substance with the lower boiling point vaporizes first, and then it is made to cool down and condense back into a liquid form, producing a more purified form of that substance. To understand this easily, imagine you have a mix of different liquids that you want to separate, like for example water and alcohol. Distillation uses heat to make one that turns into vapor first separate from the other. The one which turns into vapor first here is alcohol in this case. And when it is cooled down, it becomes liquid again. Means the vapor is made to cool down and it turns into the liquid again, which will be giving a purer form of the alcohol. So guys, this is about distillation, where it is used and how it works. Now guys, after a brief discussion on what is distillation, we will be looking at on which thermodynamic laws is distillation dependent. And to understand this concept easily, imagine that you have a mixture of different liquids. Now when you heat this mixture up to make it evaporate, there are two important laws that come into play, and which are Dalton's law and Raoult's law. Firstly, looking at the Dalton's law is like saying that the total pressure from the evaporating liquid is the sum of each individual pressure. Okay? It's as if each liquid is doing its own thing, and the total pressure is the sum of all their efforts. And Raoult's law, on the other hand, focuses on each liquid's contribution. It says that the pressure from one liquid is related to how much of it is there compared to the others. It's like the liquid is saying, I will contribute to the pressure based on how much of me is mixed in the mixture. So guys, when you put these two laws together, it's like the total pressure is a team effort, which is like the Dalton's law, and each liquid is contributing to the team based on its own characteristics is the Raoult's law. And in simple terms, Dalton's law is about teamwork and Raoult's law is about each member of the team doing its fair share based on its own abilities. So guys, I hope these laws are clear to you. I think that there might arise a question in your mind that on mixing the two liquids into one, there shall be a multiple boiling points, right? But the answer is no. The mixture cannot have multiple boiling points at a given composition and pressure. And guys, to understand it clearly, imagine that you have a pot of mixed liquids and you are heating it up. Now each liquid in that mix is like a team member and they all start turning into vapor. Okay? Understood? Okay, wait. Let me again explain the situation. Here, imagine that you have a pot of mixed liquids and you are heating it up. Okay? Now each liquid in that mixture is like a team member and they all start turning into vapor when they are subjected to heat. As you heat it, the vapor pressure of each liquid goes up. And this is like saying each team member is getting more energetic and pushing harder to turn into a vapor. Clear? Now, here's the key point. The total vapor pressure is the sum of all the individual pressures, right? It's like adding up the efforts of each of the team member. So when you are heating up the mixture, the total vapor pressure is going up because each team member is contributing more. And this means the mixture does not have different boiling points at the same time. It's like the whole team is working together and this all hits the boiling point as a group. In simpler terms, hitting the mixture makes every one of the team more excited and they all reach to the boiling point together. No one is holding back, it's like a team effort. So it summarizes like the mixture cannot have multiple boiling points at the given composition and pressure. I hope this concept is clear to you. Now furthermore, we will be looking at why it is impossible to completely purify a mixture by a distillation process. So when you try to purify a mixture using distillation, something interesting happens. At the mixture's boiling point, all the different liquids in it starts to turn into vapor. But here's the catch. The amount of each substance in the vapor depends on how much it contributes to the overall vapor pressure of the mixture. So you see, the compounds with high partial pressure will be more in the vapor, while those with lower partial pressure will be left into the liquids. But here comes the tricky part. No component in the mixture can have zero partial pressure, and this is where the things get a bit tricky. In other words, it's impossible to get a completely pure sample of one component through the distillation process. However, you can still get quite pure samples when one of the component has partial pressure very close to zero. So to sum it up in a nutshell, distillation can't give us 100% purity because each component contributes something to the vapor, making the perfect separation impossible. Okay? So this topic summarizes that it is hard or nearly impossible to completely purify a mixture through distillation process. Now next in this video, we will be exploring the wonders of distillation. Distillation, a technique with a history dating back to 3000 BC, has found its way into various crucial applications. To begin with, evidence even points to the distillation of alcohol in the 9th century. Means the process of distillation or the operation of distillation has a very long back history and was also used in the ancient times. Okay? Now let's dwell into the important uses of distillation or the applications of distillation. Firstly, one of the key roles of distillation is in water purification. Many desalination plants use distillation to turn the seawater into a drinkable water, helping to meet our thirst for fresh water. So, we were speaking of water, right? But that's not all. Distilled water has diverse uses. It's not just for drinking, it's also handy in lead acid batteries and those low volume humidifiers that can make the air a bit less dry. So, the distillation has also a wider application in the lead acid batteries and low volume humidifiers. Now, let's talk about the party essentials, the alcohol beverages. Moving on, distillation is the go-to method to purify the drinks like beer and spirits. I hope this advantage is clear to you. And not to forget, distillation brings us delightful scents and flavor. Perfumes and food flavorings often come from the herbs and plants through these methods, creating those pleasant aromas and taste we love. But it's not all about the liquids we consume. Okay? Adding to the mixture, there's oil stabilization. Distillation helps control the vapor pressure of the crude oil, making it safer for storage and transportation. Then the next application of distillation is cryogenic distillation, which helps separates the air we breathe into its components, which is nitrogen, oxygen and argon. It's like distilling the air for specific needs. And lastly, zooming out to the bigger picture, distillation finds a home on an industrial scale. It purifies liquid products obtained from the chemical synthesis and ensure the quality we expect. And one more and the largest application of distillation is for the the crude oil purification or the crude oil treatment, from which we get a wide application of products which we use in our daily lives. So there you have it. To sum it up, distillation isn't an antique technique. It's a versatile method making waves in various aspects of our daily lives. So guys, that's all for this video, where we discussed about what is distillation, then which laws are dependent on distillation. Then we also discussed about why a mixture does not have a multiple boiling points. Then we also discussed about why it is impossible to completely purify a mixture by distillation process. And at the end we also looked about some applications of distillation. I hope this video is clear to you. Thanks for watching, and for more videos related to chemical engineering, process engineering, chemical safety, industrial safety, you can subscribe to this channel. And guys, feel free to leave any questions or comment down below. Thanks for watching and see you in next video.